Hello friends, I am Yashwant Kanetkar and today let's begin with the very first C program of this course. We will keep things very simple to begin with. I will start off with a statement saying P equal to 1000.5. Then one more variable N having a value 3 and R holding a value 15.5. Then I would say simple interest equal to P into N into R slash 100. We are using the standard simple interest formula. Now every single variable we use in a program needs to be declared at the beginning. So three variables P, R and SI, they are likely to have a floating point value or a float value in them. Hence declare them at the beginning by saying float P, R, SI. Unlike them, the variable N is going to hold a value 3, which is an integer. Hence we should declare N to be an integer variable. Note that a float variable can hold a real value or a float value, whereas an int variable will hold only an int value. Do realize that when I say SI equal to P into N into R slash 100, that slash, try to make use of a backslash. That doesn't work. Don't try to set 2 upon 3. Don't use this symbol for a division to indicate 2 divided by 3. So all these three are wrong. The only way we can carry out division in C programming is using the slash operator. So every variable must be declared. That's the first rule that we have learned. Secondly, these plus, minus, star, slash, these are arithmetic operators. The way slash is used for division, star is used for the multiplication operation. Lastly, if you observe carefully, at the end of every statement, we are using a semicolon. So first statement ends with a semicolon, then second ends with a semicolon, third ends with a semicolon, so on and so forth. This semicolon really stands for a statement terminator. The way in English language you terminate a statement or a sentence using a full stop, similarly in C language you terminate a statement using a semicolon. Once you have written a statement and given a semicolon, you are free to write the next statement in the very same line. Good practice is to write them in different lines as we have done in this program. But if you so desire, you are allowed to write multiple statements in one single line. So long as they are separated from one another using a semicolon, they are perfectly okay. Fine. Let's see what has happened in memory because of our program. For P, N and R, 3 locations must have been chosen. Values 1000.5, 3 and 15.5 must have been stored in them, and the names P, N and R must have been given to them. That's what has happened in memory. So when I say SI equal to P into N into R slash 100, realize that we are not multiplying alphabets P, N and R. The moment we use the variable name P, the value that is stored under that location, in our case 1000.5, will be multiplied with the value that is stored under location name N, that is 3, and the result would then be subsequently multiplied with 15.5. Whatever result you get out of these multiplications, that is finally divided by 100. Value that you obtain out of this will be stored in yet another location. Maybe P into N into R slash 100 turns out to be 465.25. So that is stored in yet another location and a name SI is given to that location. But what is stored in this location is not visible to me with a naked eye. So I need some agent who will pick the value from this memory location and display it at a place where I can see it. That agent is a function called printf, and the place where it will display the value of SI is naturally the screen. That's your output device. The way to employ this agent printf is to say printf, then a pair of parentheses and the variable whose value we wish to print on the screen. In this case, it is SI. Tomorrow, if I want to see the value of P on the screen, we would naturally say printf P. Similarly, printf and printf R also can be employed. Right now, we are of course interested only in printing the value of SI. Note that just saying printf SI is not enough. Before SI, we need to use within double quotes what is known as a format specifier. So this %f that we are using is known as a format specifier. Every format specifier begins with a percentage. F indicates that we are trying to print out a float value. SI is a float variable. That's why we employed %f. Tomorrow in some other program, if SI turns out to be an int variable, we would employ %i. And in yet another program, if SI is a char variable, we would employ %c. So %f, %i, %c are format specifiers used for printing out a float, an int, and a char respectively. Notice that with printf, what we have used is a pair of parentheses. Don't call them as rounded brackets, that's wrong terminology. Always use this terminology: parentheses, braces, and brackets. They are distinct, they are different. In C programming, all three are allowed, but each is used with a different purpose in mind. So with printf, we should always employ a pair of parentheses. Now what we have done so far is this. If you notice carefully, here we have said P equal to 1000.5, N equal to 3, and R equal to 15.5 in one single line. Again, notice that we have managed to separate them using the statement terminator, that is semicolon. Now we need to somehow or the other be able to tell the machine what is it that we want to get executed from it. Whether only first 2 statements or 5 statements or 7 statements, which statements we want to get executed, that we have to instruct the machine. The way to do so is to put all these statements under a collective name main, such that it becomes easier for us to communicate to the machine as to what is it that we wish to get executed. If we just say execute main, then all statements that belong to main would get executed. Main, for that matter, is known as a function. Why is it a function? Well, because in C programming, the rule is that any word followed by a pair of parentheses is always known as a function. So main hence qualifies as a function. Then what statements belong to main? That's indicated by enclosing all those statements within a pair of braces. These braces are known as scope delimiters. They are so known because they basically are used to delimit the scope of main, indicate the scope of main, indicate what statements belong to main. Whatever falls within those pair of braces belongs to main. Notice also very carefully that whatever is within the pair of braces has been indented to the right using a tab. Follow that habit very faithfully. Wherever you define a function, put the statements within a pair of braces, give a collective name to those statements, and then indent the statements to the right using a tab key. Don't use spaces, always use a tab. Then preceding main, if you observe carefully, we also said int. That int indicates what type of value the function main is going to return. And the convention is that at the end of main, you always return a 0, indicating success. 0 in C programming would always mean success. Non-zero value would mean failure. Since every statement above return 0 has been executed successfully, we are saying return 0 at the end. Also realize that 0 can be written within a pair of parentheses, or if you so desire, you can drop the pair of parentheses. In that sense, pair of parentheses is really optional. Your choice whether to use it or not. Tomorrow in some other program, you have maybe 100 statements. And within those 100 statements, there are several operations that you are carrying out. If one of the operation fails, you may return a value 10. If another operation fails, you may return a value 20. If the third operation fails, you may return a value 30. So these non-zero values that you return, they always indicate failure. If there is no failure in all the 100 statements, then at the end you can return a success by saying return 0. So always say int main at the top and return 0 at the bottom. Part and parcel of every C program. Lastly, we should also say hash include stdio.h at the beginning. That symbol that we are making use of is known as a hash. Include is what is known as a preprocessor directive. What it is, we will get into that a little later. As of now, just understand that stdio.h stands for standard input output.header file. It is necessary to include this file for the printf to be able to work. Most of the library functions, if we have to make use of, library means ready-made functions. Printf happens to be a ready-made function. Anytime we have to use these ready-made functions, we will have to include a suitable file. For printf to work, we are required to include the file stdio.h. So much about the very first program that we wanted to learn in this course. Now, whenever we write a program, make sure that at the top you always give the purpose of the program in the form of a comment. That comment should always be enclosed within a pair of /*/ combination. You are free to give whatever text you want within this /*/ combination. It's going to be treated as a comment. Needless to say, you can give any number of comments anywhere within the program. At the top, in the middle, at the bottom, wherever you wish. Usually what is given in this comment is the purpose of the program. Secondly, the author of the program. Thirdly, the date of creation of the program. These three are almost there in every single program as comments at the top. Best way is now, take the next step, type out this program, get it executed. You are free to make use of absolutely any compiler that you desire. Make use of the good old Turbo C++ if you wish, or make use of Visual Studio, or make use of GCC compiler. Or if you do not want to install any of these on your machines, then you can always go online to onlinegdb.com. Once you do that, within the browser you are supposed to type out your program and get it executed by hitting the F6 key. So use any compiler. With all compilers, this program is bound to work. That I think is the best step forward. Because more programs you do, better will be your confidence level. On that note, I think we'll stop here. Goodbye, good luck, and thank you. Good morning, friends. I am Yashwant Kanetkar, and today we propose to understand one very, very important set of operators in C programming, namely the conditional operators. And best way to understand them will be with the help of a program. So let's straightway begin with a program. Suppose we have a simple program like this. We have two variables A and B holding values 3 and 4. And then we are simply checking whether A is less than or equal to B. If so, print out a alphabet A, otherwise print out alphabet B. So we have done this using if and else. We want to replace this if and else with conditional operators. Just see how. Output naturally will be A, because 3 is indeed less than 4. So this condition will turn out to be true and A would then get printed out. Now if you are to replace this if and else with conditional operators, the way to do so is to say within main first the declarations, and then I'll completely drop the keywords if and else. Instead, we would straightway write a condition saying A less than or equal to B, question mark printf A, colon printf B. This question mark and colon that we are using here, they qualify as conditional operators. And the way they work is very simple. If the condition is true, then whatever is after the question mark, in this case it is printf A, so that would go to work. However, if the condition fails, then what is after the colon part, that is printf B, that's bound to go to work. So question mark and colon are conditional operators. They are also known as ternary operators. Ternary because they need 3 operands to work with. If an operator needs only 1 operand, it becomes a unary operator. For example, if I say A equal to plus 35, that plus is working only on 35, so that's a unary plus. But if I say A equal to C plus D, for the plus to work C and D, 2 operands are needed, so that becomes a binary plus. Question mark colon in fact need 3 operands, that's why known as ternary operators. And let me also tell you that these are the only ternary operators available in C programming. All other operators are either unary operators or binary operators. Now let's take a very simple program. If A is less than or equal to B, print out A. I want this set of instructions to get converted into a program that makes use of conditional operator. Just see how. This part remains same. No reason why those statements have to change. And then I will drop the if. I would straight away write the condition followed by that question mark printf A. Since there is no else block in the first program, hence we have dropped the colon part in the second program. Everything seems to be correct. However, when we execute or when we even attempt to compile the second program, it would result into an error. And the error arises because colon is not optional. Anytime you use question mark, you are duty bound to make use of colon, which is unlike if and else. If you use a if, else is optional. If you need it, use it. Otherwise, forget about it. Whereas with question mark colon, it is not so. If you use a question mark, you have to make use of colon. You cannot drop it. So let's rectify this program now. If we are to remove the error from the program, we would say A equal to 3, B equal to 4, followed by which I would say A less than equal to B, printf A, then colon. As you can see, I am using a colon. And then since we do not want to do anything in the else block, hence in the colon part, I have not written anything. Fine. Now when I try to compile this again becomes a error. Colon is certainly necessary because colon we said will be necessary anytime we use question mark. However, one more rule is that colon block cannot be empty. There has to be something present there. Because it's a ternary operator, it would need 3 operands. So A less than equal to B is 1 operand, printf A is another operand, and something more, that is the third operand would be needed beyond the colon. We cannot just leave it empty. Semicolon that we are using at the end, that's merely a statement terminator. So between colon and semicolon, we need to give something. Let's see what we can do. Since in the colon block I do not wish to do anything at all, what we have done is we have written the null statement. We know that semicolon if we use, that's a null statement. So first semicolon stands for null, second stands for statement terminator. Whereas compiler is thinking it exactly the other way around. It treats the first semicolon as terminator. Second semicolon it treats as if you have written it in a separate line, so that's a null statement. Now don't attempt to write one more semicolon in between this, because if you do so, then that will become the terminator and the other two would become the null statements. So if we want to eliminate the errors from this program, we have 2 solutions really. Number 1 is, in the colon part, write some dummy printf statement which doesn't print anything. Similarly, you may also use some variable z, assign it some value 3, define z at the top. something or the other you will have to give in the colon part. You will agree that printf and the empty pair of double quotes, similarly z equal to 3, these are merely dummy statements. They are not serving any other purpose other than perhaps satisfying the ego of that colon. It needs something, you gave it something. Functionality wise, those statements do not really do anything for us. In that sense, they are merely dummy statements. Let's conclude what all we have learned here. Number one is, if you use a question mark, you are duty bound to use a colon. They always go hand in hand, they always go together. In the colon part, we cannot keep it empty, we have to have some or the other dummy statement. We learned that. Do not think for a moment that question mark colon is a replacement for if else. Why? Because it has limitations. Limitation being that in the question mark part and in the colon part, you are allowed to have only one single statement. You cannot have multiple statements, which was not the restriction with if and else. You could have as many statements as you wish. Then, if I say discount equal to 10, discount equal to 0, I am now using one single statement. But if that is the assignment statement, do not forget to parenthesize them. If you forget the pair of parentheses for the second statement, that is this equal to 0, that would result into an error. Don't do that. Here we can see discount equal to 10 as well as discount equal to 0, both have been parenthesized. Lastly, nesting of question mark colon can be allowed. Means within question mark part, you may have one more condition and a question mark colon for that. Similarly, in the colon part, you may have one more condition, again a question mark colon for it. That makes the statement complicated, but for the academic standpoint, is it permitted that we nest the conditional operators? Answer is yes, you are allowed to do that. So much about the conditional operators that can be used in a C program. Goodbye, good luck, and thank you. Hi friends, my name is Yashwant Kanetkar and I am here today to discuss with you some of the intricacies of functions in C programming. I am sure you already know how to define a function and how to call it from different places within your program. First intricacy that I would try to discuss with you is the fact that in C programming, as far as functions are concerned, nobody is nobody's boss. By this what I mean is that if you have a program wherein you first make the declarations of two functions, Bombay and Kanpur, we know that these are known as prototype declarations of functions. Every single function that we make use of in our program, its prototype is necessary, where prototype contains what? Name of the function, any value that you pass to it, and the return type of the function. And then within main, what I would do is I would make a call to a function printf first. Printf is different than Bombay and Kanpur in the sense that printf is a library function. And then I'll make a call to Bombay, followed by that a call to Kanpur. Then let's define the Bombay function, wherein I will print out a message saying I am in Bombay, following which I am making a call to the Kanpur function. Lastly, let's define the Kanpur function, where we print out a message saying I am in Kanpur, and then follow it up with a call to the Bombay function. So when you attempt to execute this program, execution we now know begins always with main. So first thing that would get printed is I am in main. Following that, there is a call to Bombay function. So control will jump to wherever Bombay is defined. So it will bring the control here. Here Bombay would get executed, as a result of which this printf goes to work. I am in Bombay gets printed. And now there is a call to Kanpur, which will bring the control wherever Kanpur is defined. Once it reaches Kanpur, it will print out I am in Kanpur. And then notice that there is a call to Bombay. This call to Bombay will do what? It will simply bring the control once again back to Bombay. Again I am in Bombay would get printed. Again there is a call to Kanpur, so control will jump to Kanpur. I am in Kanpur will get printed. Call to Bombay brings you back to Bombay. What has really happened? Bombay keeps calling Kanpur, Kanpur keeps calling Bombay. You and I are stuck up in an infinite loop. How to get out of this infinite loop is something that we would figure out. But what is important for you to note here is that neither Bombay is Kanpur's boss nor is Kanpur Bombay's boss. Nobody is nobody's boss. Any function is free to call absolutely any other function. The way Bombay can call Kanpur, Kanpur can call Bombay. The way main can call Bombay and Kanpur are in complete right of themselves to be able to call main. So don't be surprised tomorrow if main is called from Bombay. Perfectly okay. You are not violating any rule by doing so. So absolutely any function can call any other function. That's the first intricacy that I wanted to bring to your notice. Let's move on to the next one. Suppose we define Bombay first and then we define main. Realize that this is perfectly acceptable. And also notice that when you do so, you can do away with the prototype declaration of Bombay. Nowhere do you see the prototype which we had done in the previous program. There is no prototype of Bombay below hash include. Straightway you define Bombay and then you define main. Just because you define Bombay before main doesn't mean that execution will begin with Bombay. Execution always begins with main. That's why it's known as entry point of the program or EP of the program. So even though main is the second function, execution will still begin with main. I am in main will get printed. Then there is a call to Bombay. It will bring the control to Bombay. And Bombay would get executed. Once Bombay's execution is over, control will go back to main, and then you reach the closing brace of main, as a result of which execution comes to an end. So Bombay, if you define before main, then prototype is optional. You are free to define functions absolutely in any order. Their order of execution is dictated by the order of calls that you make to them within main. And also remember, execution will always start with main. As I mentioned, prototype of Bombay in this case is optional. That brings us to the third intricacy, wherein, if you observe carefully, now that we have defined Bombay after main, we have taken care to declare the prototype of Bombay. And all that we are doing is, we are printing out main, then in a loop, 20 times we are making call to Bombay. First call to Bombay brings the control to Bombay, executes Bombay, goes back. Again there is a call to Bombay, again it lands into Bombay, executes it, and goes back. So Bombay keeps getting called 20 different times. Instead of getting it done this way, we can get exactly the same output had we written the loop within Bombay rather than within main. Out of these two, if you ask me which is a superior program, output of both the programs will be same. But second is superior for the simple reason that you do not keep shuttling between main and Bombay as you are required to do within the first program. In the second program, you call Bombay only once. You land into Bombay, run a loop there, do all your printing there, go back once and forever. Lesser the number of calls, faster will be the speed of execution of the program. More function calls you make, more will be the time that is required for executing the program. That's why in general I am saying more the calls, lower is the speed of execution of the program. Bear this in mind as you define newer and newer functions in this course. On that note, we'll stop here. Goodbye and good luck. Hi friends, I am Yashwant Kanetkar, and today we propose to begin with one of the very important topics in C programming, namely pointers. I am sure you have heard enough horror stories about pointers. Yes, indeed, pointers remains one of the biggest hurdle in anybody's C programming career. Any program of a reasonable length will always have some or the other form of pointers. So let's put our best foot forward and try to understand this concept. I'll begin with a very simple program wherein within main all that we do is create a variable by saying int I equal to 10. And then I wish to print the value of I. I do so by saying printf I, and naturally we should use %d to be able to get 10 printed out. Very straightforward. Let's see what happens in memory when we do this. We know that memory consists of multiple cells, in fact millions of cells. If these cells are given numbers like 0, 1, 2, 3, etc., then when I say int I equal to 10, one of these cells will get chosen. Maybe there is a cell whose number is 4080 that gets chosen. Which one will get chosen? Over that we have no control. But assuming that a location number 4080 gets chosen for I, the value 10 would get stored in it and the name I will be given to that location. So when I say print value of I %d I, value stored under location 4080, that is 10, will get printed out. As I said, we cannot exercise control over where I will be granted a location. But once it has been granted a location, you can always inquire, you can always figure out which location has been granted to it. And you can do so by asking for its address, that is 4080, which is also known as a reference or a memory location or a cell number. To me, out of these four terms, address is the one which makes most sense, for the simple reason that the place where I stay, that's my address. Similarly, the place where the variable I is storing, that is the address of the variable I. And I can print out that address by saying and I, where and that we are making use of stands for address of operator. The way you have plus, minus, star, slash as arithmetic operators, similarly and happens to be an operator whose name is address of. Address of what? Address of the operand. In this case the operand is I, hence address of I. In our case that address of I is bound to be 4080, and this being a whole number we will print it using %d. If I wish to print value of I in one more way, I can do so by saying and I, means first get me the address of I, and then I am not interested in the address, I am interested in the value present at that address. That I can obtain by saying star of and I, where star happens to be another operator known either as an indirection operator or as a value at address operator. Out of these two, value at address and indirection, to me what makes more sense is value at address. Because if and I gives you 4080, then if you treat star as indirection operator, indirection of 4080 is not very meaningful. Instead, if and I gives you 4080, then star if you take as value at address, you can say get me value at address 4080. And from the figure you can very well see value at address 4080 happens to be 10. So 10 is bound to get printed out. By the way, these and star together are often known as pointer operators. So if 10 is to be printed out, we should naturally employ %d as the format specifier. And then finally put a closing brace. So all that we have learnt here is that and is address of operator, star is value at address operator, and together they are known as pointer operators. In fact, with that we are actually done with pointers. We are through with pointers. Don't believe me? Well, that is the only thing that is to be learned. Anytime you have any problem in future about pointers, just ask yourselves two questions. First should be, what does AND stand for? And second should be, what does star stand for? And whenever you ask these questions, always answer yourself very convincingly that AND is address of operator and star is value at address operator. If you do that, believe me, you will not face any problem with pointers. Now let's try a few variations. Suppose I say int I equal to 10 and then I say in j store address of I. Will that be legal? Perfectly. Can I say j equal to and 23 or j equal to and I plus 34? Well, first among this is okay, whereas next two are not. The reason why next two are not okay is because you cannot take address of a constant like 23, nor can you take address of an expression like I plus 34. In other words, I can say that AND can be used only with a variable, never with a constant, never with an expression. Let's look at what is the story with star. Star j you can do, star 4, 5, 6, 8 also you can do, star of 4, 5, 6, 8 plus 1 also you can do. Means star can work with a variable like j or a constant like 4, 5, 6, 8 or an expression like 4, 5, 6, 8 plus 1. So first is okay, second is also okay, third is also okay. So if I am to generalize, I can say that AND can be used only with a variable, never with a constant, never with an expression. Unlike that, star can be used with a constant, a variable and an expression. Don't immediately start typing star of 4, 5, 6, 8 or star of 4, 5, 6, 8 plus 1. They would not straightaway work. You will have to do something more for them to work. What is that something more? We will see as we go along. But as of now, understand that AND can work only with a variable, whereas star can work with a variable, constant as well as an expression. So much about AND and star operators. Once you understand them, you are well on your way to write programs which make use of pointers. Do try to execute this program. That's the only way to grow in confidence. Goodbye and good luck for now. Hello folks, I am Yashwant Kanetkar and today we propose to start with yet another very important concept in programming, namely recursion. Suppose we have a simple C program wherein within main we make a call to a function printf, following which we make a call to main itself. Can I do this? Well, if you remember, we had said that any function can call any other function. Similarly, if main calls itself, that's perfectly fine. On execution, you'll observe that this results into an infinite loop. Because execution starts with main, printf hi goes to work, then call to main brings the control back to main. Again hi gets printed, again call to main brings us back to main. This goes on indefinite number of times. So in that sense, we have fallen in an infinite loop. Let's look at one more possibility, wherein from main I call some function, maybe fun, and then within body of fun we make a call to the fun itself. At the top we need to have prototype of fun. So execution starts with main, call to fun brings the control to fun, then hi goes to work, call to fun brings the control back here. So fun keeps calling itself, again it becomes an infinite loop. So if main calls itself, it's an infinite loop. If fun calls itself, that's also an infinite loop. In fact, anytime a function calls itself, that function is known as a recursive function, and the process of calling itself, that process is known as recursion. One of the very important techniques that you learn in programming. But a function calling itself and falling in an infinite loop is really not going to serve any useful purpose. you need to somehow or the other make a provision to get outside this infinite loop once meaningful work has been done within that function. Let's see how this can be achieved with the help of a program. What we wish to get is recursive sum of digits of a given number. For that, I'll start with main, ask the user to enter a number, scan its value. And then, if the number is 327, we'll pass that 327 to a function called rsum. R because we are planning to make use of recursion within this rsum function, recursive sum of digits. It should calculate the sum, return it, we'll collect it in some variable sum and then print it out. Needless to say, num and sum have to be defined at the beginning. Let's now try to define this rsum function. Num that we have passed we'll collect in sum int n. And before we actually get the sum of digits, let's look at another parallel theme wherein we wish to get factorial value of a number 4. We know that this is nothing but 4 into 3 into 2 into 1. Out of which 3 into 2 into 1 I can always represent as 3 factorial. So 4 factorial is really 4 into 3 factorial. Where 3 factorial itself is what? 3 into 2 factorial. And 2 factorial is 2 into 1 factorial. Lastly, 1 factorial is nothing but 1 into 0 factorial. We cannot go below 0 because factorial of a negative number is not defined. Point I am trying to make is that 4 factorial is expressible in the form of itself. 4 into 3 factorial, when I say 3 factorial, I am expressing 4 factorial in terms of some other numbers factorial. So any logic which is expressible in the form of itself is something which is programmable using recursion. What applies to 4 factorial equally applies to sum of digits of 327. Sum of digits of 327, I can look upon that as 7 plus sum of digits of 32. The way I say 4 factorial is 4 into 3 factorial, similarly sum of digits of 327 is 7 plus sum of digits of 32. If we are to get that done, first we need to extract the digit. We can do so by saying d equal to n mod 10. And then reduce the number to 32 by saying n divided by 10. 327 divided by 10 will turn out to be 32. So in d we have 7, in n we have 32. So we can say S is equal to d plus r sum of n, 7 plus recursive sum of 32. The moment I make this call to r sum, do we agree that we have now fallen in an infinite loop? So we need to break out of it. To do that, we'll subject this call to a condition saying if n is not equal to 0, then only do this. Otherwise means else. Else do what? If n is 0, then return a 0. Because sum of digits of 0 is nothing but 0. And finally do a return s. Then put the closing brace, do define the variable d, also define s. That is how I can obtain recursive sum of digits of 327. This return 0 is perfectly understandable, that if you pass 0 to this scanf, then to r sum 0 will be passed, n will contain 0, 0 not equal to 0 would fail, you should return a 0 because sum of digits of 0 is nothing but 0. What is difficult to understand is the purpose of this return s. What purpose is it serving? You try removing it and try to execute the program, you will find that you get wrong results. Fine? So what we need to do is we need to understand this more carefully. Needless to say, at the top we will have to add prototype declaration of rsum, and we will also have to include stdio.h. That you must do at the beginning. Now, before we try to understand the purpose of that return s, let me make a couple of statements. First of which says that a fresh set of variables is created during every single call. You are calling rsum from main, you are also calling rsum from within rsum. This is the first call, this is the second call. Every single time you are bound to land here. When you land at the definition of rsum, realize that a fresh set of n, d and s would be created. Whether call happens from main or whether call happens from within rsum. Fine? Secondly, the variables would die when you return from that call. You land into a function, you create variables. When you go back from that function, the variables would die. They would cease to exist. They would vacate space in memory. Final outcome, of course, is 12. We want to understand how do we get sum of digits of 327 as 12. And to do so, all that we need to do is we need to make multiple copies of this rsum function. First copy, one more copy, yet another copy, and still one more copy. From main, the first copy gets called. What is passed is 327. Now let's try to understand the control flow. When it reaches here, n not equal to 0 will be true because n is 327. So condition is true. So d will be how much? 327 mod 10, that is 7. N will be 327 slash 10, that is 32. So s was how much? D plus rsum of n. So 7 plus rsum of 32. And this call to rsum actually brings you here. But for a moment, believe that it takes you to the next copy of rsum. So you are passing 32, you are collecting it in n. 32 not equal to 0 is true. D will be 32 mod 10, that is 2. N will be 32 slash 10, that is 3. So S becomes D plus rsum of n, that is 2 plus rsum of 3. Again there is a call to rsum. Let's say that brings us to the next copy of rsum. We land here with a value 3. So value of n is now 3. 3 not equal to 0 is true. 3 mod 10 will be done. 3 mod 10 is 3. 3 slash 10 is 0. So S becomes 3 plus rsum of 0. This again brings the control where to the next copy with a value 0. So 0 not equal to 0 fails. Control goes to else block. Return 0 goes to work. Return 0 brings the control to the place from where the call was initiated. It was initiated from here, so control will come back here. So when it comes back with a value 0 because you are returning that 0. 0 will now be added to 3. 3 plus 0 is 3. S will be assigned a value 3. Now that S has been assigned a value 3 means these statements are completely executed. So if block is over, else will be skipped. Control would land where? It would land at return. When it reaches return, S is how much? S is 3. So this return 3 will bring 3 here to the previous call. 3 plus 2 will be done. S will be 5. Now these statements are completed. So else will be skipped. You will reach return S. S contains 5. So 5 will be returned. 5 that you return will be added to 7. 7 plus 5 is 12. S is 12. Now execution of these 3 is over. Else is skipped. You reach return S. You are returning 12. Back to whom? Back to main. Main will collect this 12 and then print it out. Moral for you and me is what? That if you want to understand a recursive function, make multiple copies of it. It becomes easier to keep track of how the control is flowing, what value is being passed, what is being returned. With one single copy, it becomes difficult to understand. With multiple copies, it becomes simpler to understand. Note also the fact that only one copy is created in memory. We created multiple copies only for the sake of understanding the program. In memory, there is only one copy. But with multiple copies, it becomes easier to understand, easier to follow the control flow. So much about how do we go about writing a recursive function. Goodbye, good luck, and thank you. Hi folks. Let's today try to understand one very, very difficult concept, at least from the user's perspective, as to what really is the difference between a string and a character pointer. Let's take an example to understand the difference. Suppose I create a program wherein we say char p bracket equal to hello. And then we try 3 operations on p by saying p equal to p plus 1, p equal to by, and star p equal to m. Realize that when we say char p bracket equal to hello, p is constant. We know that name of an array acts as pointer to the 0th element of the array. In this case, the array contains hello. 0th element is h. So p acts as a pointer to h. So any attempt to say p equal to p plus 1 will be rejected because p, I told you, is name of an array, and that name of an array equal to something is always wrong. And why is it wrong is what you need to understand. Name of an array acts as a pointer, that is fine, but more correctly it acts as a constant pointer. Since p is constant, hence you cannot change it. P equal to p plus 1 is an attempt to change p, so that's rejected. Similarly, when I say p equal to by, that's also summarily rejected, because again we are saying array name equal to. Let me again re-emphasize that array name acts as what? Constant pointer to the 0th element of the array. That constantness of the array name is what prevents us from being able to make changes to it. So p equal to p plus 1 is wrong, p equal to by is wrong, p equal to anything is wrong. However, if I do star p equal to m, that's acceptable because p is pointing where? P is pointing to h. So if I do star p equal to m, this h will be replaced with m. String will become mello. Fine. So p in this case is acting as what? A constant pointer to a string. Let's look at the other one. Suppose I say char star p equal to hello, and then I try all the 3 operations again. In the first case, p was a constant pointer to a string. In the second case, p is a pointer to a constant string. 2 are different. Since they are different, hence, when I do p equal to p plus 1, that will be okay. When I do p equal to by, that would also be okay. But when I do star p equal to m, that would be wrong because string is constant here. You cannot change anything which is constant. Pointer is not constant, so pointer can be changed. That's why p equal to something is fine. Moreover, p is not an array, so you need not say that array name equal to something is wrong. P is not an array in the second case, it's merely a pointer. So p equal to p plus 1 is fine, p equal to by is equally fine. But star p equal to m would result into an error because pointer can change here, but the string cannot. So these are quite opposite to one another. In first case, p acts as a constant pointer to a string. In the second case, p is a pointer to a constant string. Once you understand this, you will realize that there is no confusion between what is a char pointer, what is a array name. Realize that char star p equal to hello could also have been written as const char star p equal to hello or char const star p equal to hello. Both of these are same, meaning very clearly that order doesn't matter. Whether you say const first or you say char star first, it's one and the same thing. Const char or char const. In both cases, p remains a pointer to a constant string. So char star p is same as const char star p is same as char const star p. Fine. One is constant pointer to string, second is pointer to constant string. These intricacies are what are important from a C programmer's perspective. Better you understand them, better C programmer you ultimately become. So do concentrate on the details, do concentrate on the nuances, the intricacies of the language. That is where the gold is. Fine. Goodbye and good luck. Hello friends. A very good morning to all of you. I am Yashwant Kanetkar, and today we are going to see how to handle dissimilar data using arrays. Let's begin with a program to understand this concept. Suppose we have such data to store in memory, maybe names of each employee, then ages, similarly salaries. For simplicity, we are taking name as a single character. In reality, we will have to see how multiple character name can be incorporated. What is important here is that each item of information that you have here is known as a field. And a collection of such fields is known as a record. And a group of such records is known as a table. Fine? Fields, records, and table. Now, if we are to store such data in memory, let's see what options are available at our disposal. First could be use as many as 12 different variables, each holding one value. From where do we get 12? Well, there are 4 records in our data. And in each record, there is name, age and salary. So we may have N1, A1, S1 as first set of variables. Similarly, N2, A2, S2, N3, A3, S3 and N4, A4, S4. So totally 12 such variables can be used. But you'd soon reject it because that's not a scalable solution. Today we have only 3 fields and 4 records. Tomorrow it might be many more. In which case, number of variables will also have to be many more. So that's not scalable, hence we should reject it. Second possibility is that, well, create an array of name, age and salary. In an array, store A, 23 and 4000.5. In another array, store X, 27 and 5000.0. Similarly, third array for third record and fourth array for fourth record. This also will have to be rejected immediately. Why? Because name is a character, age is an integer and salary is a float. These 3 dissimilar entities cannot go in an array. Yes or no? Array, as we know, is nothing but a collection of similar elements. That similar is very important. Dissimilar elements can never go in an array. So that second possibility is also ruled out. That brings us to the third possibility, wherein we create an array of names, array of ages and array of salaries. That is indeed feasible because names are all similar, so they can go in an array. Ages are all integers, they can go into an integer array. Salaries are all reals, they can go into a float array. So first 2 options are indeed wrong. Third one is very much doable. So let's see how do we implement the third option to store such data, such tabular data into memory. I'll have to do what? Within main, I'll have to create a character array having A, X, Y and Z as 4 records or 4 names. Followed of course with a \0 because char array we know always ends with a \0. Then create another array of integers storing the ages of 4 different employees and then float salary again having 4 salary values. Reason why we prefer these arrays is processing of an array is very efficient. If you have to go to every element of an array, we have to just iterate through that array using a loop. For example, in this case, if we have to print the records, all that we need to do is employ a loop which says for I equal to 0 to I less than equal to 3, I plus plus. Why less than equal to 3? Because totally there are 4 records, 0 to 3, 4 records. Each time through the loop, I can print out Ni, Ai and Si. N0, A0 and S0. That will print the first record. When I becomes 1, it becomes N1, A1, S1. Similarly, N2, A2, S2 will print third record and N3, A3, S3 will print out the fourth record. So this way we can print out all 4 records quite easily. Do define I as an integer. That's fine. However, there are certain inherent disadvantages when we make use of an array. First disadvantage is today there are only 3 fields: name, age and salary. Tomorrow in the record we may have sex of the employee, address of the employee, basic salary, gross salary, different allowances that the employee gets in salary, HRA, DA, CA, so on and so forth, income tax deduction. Means a record containing 30-35 fields for an employee is pretty common. And realize that for 3 fields we created 3 arrays. For 30 fields we will be required to create 30 arrays. And that, you will agree, will be quite cumbersome. But even if we swallow that bitter pill and create 30 arrays, still realize that there is a very, very important disadvantage that has been highlighted here. That is the natural relationship that existed in the data, that stands completely destroyed. What do I mean by this? Well, look at the first array. If I ask you how is A related with X and how is X related with Y, answer is very simple. They are unrelated. They are names of different people. Similarly, 23 has got nothing to do with 27 and 27 has got nothing to do with 28. But we still clubbed them together because they were similar. You get my point? There is no natural relationship between 23, 27, 28 and 22. We forced that relationship because they were similar, and since an array can hold only similar entities, we had no other alternative but to get all these similar integers together. Natural relationship was really between name, age and salary. I can say that 23 is age of a person whose name is A and who draws 4000.50 as monthly salary. So that relationship that exists between A23 and 4000.5, that has not been captured in the program. And that really needs to be captured. Because similar entities staying together is the limitation that language forces us to use. But natural relationship that exists within the data, that we should be able to preserve somehow. And the way to preserve that natural relationship is using a structure. And how to make use of the structure to store this dissimilar data is what we propose to understand in one of the lectures to follow. Till that time, goodbye, good luck, and thank you very much. A very good morning to all of you. I am Yashwant Kanetkar, and I am here today to discuss with you how to handle dissimilar data using a data type in C programming known as structures. If you remember, the other day we had figured out how dissimilar data can be tackled using arrays. But there were certain inherent disadvantages when we made use of arrays, and we wish to overcome them today by making use of an entity called structure. We had such data to store names, ages and salaries of employees, where name, age, salary were fields which together are known as a record, and a collection of such records we said is a table. So this tabular data, if we are to represent in memory, as I said, there are 2 choices. One is create an array of integers, that is ages, create an array of characters, that is names, and thirdly create an array of floats, that is salaries. Disadvantage is what? Disadvantage with this approach is that if number of fields go on increasing, those many more arrays will have to be constructed. And second disadvantage is that natural relationship that existed in the data, that stands completely destroyed when you create an array of names, array of ages and array of salaries. Both these limitations, if we are to overcome, we have to make use of what is known as a structure. It's a data type in C Let's see how do we make use of it. I have to begin with declaration of a structure by saying struct employee, and then indicate what all fields or elements belong to this struct employee, and that I indicate by declaring that it will hold a character name, a int age, and a float salary. This is declaration of a structure. If I ask you a question, how many bytes should be reserved for this struct employee? Well, answer is 0. Why? Because it's a declaration. Declaration, we know, never reserves space. Unless you define a variable, space is never reserved. In that sense, this struct employee is merely a blueprint, merely a template, indicating that tomorrow if you create a variable of the type struct employee, what all will it contain? It will contain a char name, int age, and float salary. As of now, is merely a declaration. When I say struct employee E, now space is reserved. How much space will be reserved? If E contains a char name, int age, and float salary, then obviously it will be 1 byte for char, 4 bytes for integer, 4 bytes for float, totally 9 bytes. Fine. Not only do I want to define E, a variable of the type struct employee, I also wish to initialize it. And since we propose to create 4 such variables, I would say E1 is equal to A23 4000.5. Similarly, struct employee E2 equal to X27 5000.0 and struct employee E3 equal to Y28 6000.75. Let's create one more variable E4 holding values Z22 and 5600.55. Advantage here is natural relationship now stands restored. It was not so in case of arrays, but it does stand restored because Z22 and 5600.55. So best way to deal with dissimilar data is what? Get it together inside a structure. Because the way array is a collection of similar elements, likewise structure happens to be what? A collection of dissimilar elements. Fine? And now to print out the value of each one of names, ages and salaries, we cannot merely say N, A and S. Why not N, A and S? Because E1 contains N, A and S, so also does E2, so also does E3, so also does E4. So whose name, age, salary are we talking about? That has to be clarified. And that can be done when you say E1.N, E1.A and E1.S. Likewise, I will say E2.name, age, salary, E3's name, age, salary, and lastly E4's name, age and salary. Finally, the closing brace of main. So using the dot operator, we can access elements of a structure. Which are the elements of the structure? Name, age and salary. Then what is employee? Employee is the structure name. What is E1, E2, E3, 4? These are structure variables. Terminology, I always insist, is very important. Structure name, structure elements, and structure operator like dot, and structure variables like E1, E2, E3, E4. This also has one serious limitation. Today there are 4 records, so we employed 4 printfs. Tomorrow if there are 400 employees, just to get their data printed out, if you have to write 400 printfs, that is certainly no way of doing things. To overcome this limitation, what we should really be creating is an array of structures. The way to do so is to first declare the structure containing name, age and salary, struct employee, and then create the array saying struct employee E, and then initiate the array to all the 4 records. Fine. So within a structure, you can have dissimilar elements, and then these dissimilar elements together can be part of an array of structures. So 0th element of this array is one collection of dissimilar elements. It is similar to the next set of dissimilar elements, is similar to the next set of dissimilar elements. So within the array there is similarity. 0th element, first element, second element. Within that 0th element there is dissimilarity. Structure is dissimilar, but that dissimilar structure is exactly similar to the next dissimilar structure, is exactly similar to the next dissimilar structure. Hence we can create an array of structures. So E in fact is nothing but an array of structures. And once we create this array of structures, just see how efficient does the processing become. Earlier we had 4 printfs. Today we can manage using only one printf. Just run a loop and then print out name age salary by saying ei.n, ei.age, ei.salary. ith person's name, ith person's name, ith person's salary. When I is 0, this will be e0.n, e0.s, e0.a, and that would take us to this record, 0th record. When I becomes 1, we are referring to elements of first record. When I is 2, elements of this record. When I is 3, elements of this record. So this way processing of all records becomes very efficient the moment these records become part of an array. Finally put a closing brace of main. So any tabular data here on you would ever see, immediately realize that that tabular data can always be managed using one single variable, that is an array of structures. So tabular data can always be dealt with using an array of structures. E in fact is nothing but an array of structures in our program. Advantage is what? That this single variable can tackle any number of records and any number of fields. So let the tabular data have 1000 records and 30 fields in each record. We still need only one single variable. Means as the data volume goes on increasing, my variable names don't go on increasing. I can deal with all records, no matter how many of them exist, no matter how many fields are there in each record, using what? One single variable, that variable being an array of structures. Really a very powerful variable. With that we come to the end line. Goodbye and good luck. Hello friends, I am Yashwant Kanetkar, and today we wish to understand in detail what is known as a build process. Very often students commit a mistake when they say that they are compiling a program by doing Control F5 or Control F9 or F6 or whichever key shortcut is there in the compiler that you are using. They say that they are compiling the program, whereas in the real sense they are actually building the program, because compilation happens to be one small step in the build process. Often people spend so much time every day in compiling the program, they do not realize that it's only a small step in the build process. That should not happen in your case. You must know the build process completely. That is why I am going to get into the details of this. Story always begins with a handwritten program. You always first write it on paper to see whether it's working on paper. Once that is there, then you start typing it in using some text editor, VS Code or Programmer's Notepad or whichever editor you might be using. Once the program has been typed and saved, there onwards it's known as C source code. Get used to this terminology. Now this C source code is what we submit to the compiler. But realize that when we do so, for example in Visual Studio, if you do Control F5, you are not initiating compilation, you are initiating the build. Within that build process, the very first step would be pre-processing of your program. There is another program like compiler known as preprocessor. Compiler is often known as processor. Since this program gets to work with your code before the compiler, it is known as a preprocessor. What does the preprocessor do? Well, it takes input as your C source code and expands upon it. Based on the preprocessor directives that you may have used within the program, your code will get expanded. It is this expanded code which is handed over to the compiler. Your source code is never handed over. Expanded source code is given to the compiler. Compiler naturally will do what? It will create what is known as assembly language code. This assembly language code is then submitted to the assembler, which creates what is known as object code. This object code is in machine language. And then in the build process, next actor is linker. It combines the object code of your program with object code of library functions. Since it combines the two, it links the two, the program is known as a linker. It links the two and creates what is known as executable code. It is this executable code which you actually get to execute. Means tomorrow if somebody asks you what is it that you mean by building a program, don't say it means compiling. It means what? Preprocessing, compiling, assembling and linking. All these 4 steps together constitutes the overall build process. Fine? So text editor's job is to do what? To let you type the program and modify it if there are any mistakes in it. Preprocessor job is to expand the source code based on the preprocessor directives used in the program. Just to give you an example, hash include stdio.h happens to be one of the preprocessor directives. How do I know that? Well, because it begins with hash. Every preprocessor command or every preprocessor directive always starts with a hash. That hash in fact signals this preprocessor that you got to do something with this. When you do hash include stdio.h, what this preprocessor does is, it reads stdio.h, brings in the code present in it, places it right where you have done hash include stdio.h. And what it contains is prototypes of variety of library functions. For example, printf and scanf you are using, their prototypes are in stdio.h. You include them, bring them, paste them where hash include is there, and then you make calls to printf and scanf from maybe within main. So calls will happen within main. Prototypes have to be available. They have been brought in from stdio.h by using the preprocessor command hash include stdio.h. So that should give you a perspective about what is the role of preprocessor. It expands upon the source code, generates the expanded source code. This is handed over to the compiler. Its job is to convert the expanded source code into assembly language instruction. These are readable instructions, human readable instructions. But when you submit this to the assembler, it generates what? Machine language code. Object code is always in machine language. Linker combines object code of our program, means machine language code of our program with machine language code of library functions, which are made available to you in a pre-compiled form. They are already in object code form. So the two objects or object codes are linked together using the linker to generate what is known as executable code. Fine? That's the overall build process. When I say that C source code is created or expanded source code or assembly code or object code or executable code, these codes are what? These codes are files present on your disk. For example, C source code you usually store in a .c file. Maybe your file name is pr1.c. When the expanded source code is created by preprocessor, it will also have to be stored in a file. It will usually have extension .i. So pr1.c on expansion will get stored in pr1.i, which on compilation will get stored in pr1.asm, which on assembly will get stored in pr1.obj, which on linking will get stored in pr1.exe. So all these different files get created for every single program that you build. So here onwards, don't say I am compiling a program, always say I am building the program. Because it goes through all these steps every time you do Control F5 in Visual Studio or Control F9 in Turbo C or F6 in online GDB. You understand this? So that overall build process is very important for you to understand. You must know the process. You must know what is happening behind the screen. Those behind the screen activities, if you know, by the end of the day, you will end up becoming a better programmer, which is what is the motive of our course. Goodbye, good luck, and thank you. Hello friends, I'm back today to explain to you the relationship between structures and pointers. To that, I will create an array of structures of the type struct employee. Suppose this is the array containing values like A23 400.5, X27 500.0 and Y28 600.75. These being array elements, we certainly expect them to be in adjacent memory locations. Now, if I do P equal to E being an array, if I mention its name, I am bound to get its base address. Base address of the array is how much? Well, it's 401. So in P, what would get stored is 401. Then I do a P++. And then I print out the value of P. Now if I ask you, having done P++, printf P would give me what? Your answer could be, well, it will give me 410 or 402. If I do a P++, what I get depends upon what is the type of the pointer. And you would not be able to tell me whether it's 402 or 410 unless and until I tell you what is the type of the pointer P. So don't think that plus plus means go to the next byte. What and where it will take me depends on what? Depends upon the type of the pointer. Because the rule is, to increment the pointer, it points to the next location of its type. That of its type is very important. So unless type of the pointer is known, you would never be able to tell me where would P++ take me. Suppose I define P in such a manner that I should get 402. Then how would the definition look like? Well, it should merely be a char pointer. Then only plus plus will take me to the next char. Yes or no? Unless and until P is a char pointer, plus plus on it will not take me to the next byte or next char. So I would have to define P as a char star P. Then I may do Q equal to E, again do a Q++, and then print the value of Q. I want that this should give me 410. A char pointer on incrementation takes you to the next char. Then I must think of Q as a pointer which will take me to the next structure. Right now Q is pointing here. So also is P. But if I increment Q, if I want that Q should take me here to the next structure, I should think of Q as what? A pointer to a structure. Then only it will take me to the next structure if I define Q and then increment it. Let's define Q as struct employee star Q. When I do this, now Q++ will take me to 410. So P is what? P is a pointer to a char or a char pointer. Similarly, Q is what? Q is a pointer to a structure or a structure pointer. Both are one and the same thing. The way char pointer is same as pointer to a char, similarly, structure pointer is same as pointer to a structure. I do R equal to E and R++. Let's define R to be struct employee star R bracket 3. The moment I define it this way, R becomes what? R becomes a pointer to an array of structures. If it is a pointer to an array of structures, then on incrementing it, I will be taken to the next array of structures. next array of structures will begin at 428. Means we are thinking of R as if to begin with it's a pointer pointing here, and I am saying that it's an array of this and it's a pointer to this entire array. Plus plus on R, I expect that it should take me here. 419, then 28 will be at 420, 21, 22, 23. 600.75 would be at 424, 25, 26, 27. 4 byte float. So this will be really at 428. I want to reach here, so I should treat R as what? As a pointer to an array of 3 struct employees. And these parentheses you appreciate are vital. If I do not use parentheses the way I have done here, then Z becomes what? Z becomes an array of pointers to structures, which is fundamentally different than pointer to array of structures. Differences are what really? If I do a Z equal to E and then I try Z plus plus, that would be wrong. Why would Z equal to E be wrong? Because Z is an array now, and array name equal to something we know is always wrong. No matter what is the type of the array name equal to something would never fly. So this is wrong. Again, to reiterate, P is a char pointer, Q is a pointer to a structure, R is pointer to an array of 3 struct employees, and Z is an array of 3 struct employee elements. Array of structures and pointer to an array is something which is different. Q, R, do we agree that all of them would be 4 bytes each? Because ultimately all these 3, P, Q as well as R, contain nothing but one address. Whereas Z is supposed to hold 3 addresses. One address 4 bytes, so 3 addresses would be 12 bytes. That explains as to why PQR is of 4 bytes, whereas Z is going to be of 12 bytes. I hope I have clarified enough the difference between different types of pointers. Moreover, the difference between pointer to an array of structures and an array of pointers to structures. Those R and Z, those are very vital. The rest I think is fairly straightforward. Bye and good luck.